Okay, now let's move on to the question 19. We have a quadrilateral AB and CD. Right, so we have the AC and the BD. At E, we have the M is the midpoint of AE, and N is the midpoint of DE, respectively, and the BM is trisect angle B, and the CN is trisect angle angle C, right? So let's parameterize it. So it's angle trisector, right? Yeah. So if we have two lines are parallel, right, and by cutting this, we know this angle plus this angle is 180, right? That's B and C, and we know this angle equal this angle, right? So now you know this angle is 2 alpha, right? And we also know the C, the B is 3 alpha, right? Plus the C is equal to the 180. Then you can see each component, each part of the C trisector, right? Each part of this is 60 minus alpha. Now you know this angle is 2 of 60 minus alpha, right? So this angle is 120 minus 2 alpha. Okay. Now let's see what's going on. And also we haven't used the midpoint, right? So that means the AM equals to ME, right? And take a look at the BM, okay? So here the B in triangle ABE, and we have the BM is the angle bisector, and the BM is median. What kind of things have such properties? Angle bisector and median. Both is angle bisector and the median. It must be isosceles triangle, right? So we know that AB equals BE. Let's do it. So let's see AB equals A and BE equals A. Right? And let's, same thing, you can see the CD equals the CE, right? Okay. Now we also see, because this is the isosceles triangle, right? ABE is the isosceles triangle, so you can see what's this angle, right? So angle of the AEB, right, is 180 minus the 2 alpha plus the 120 minus 2 alpha, right? So it's 60. So now you know this angle is 60, this angle is 60, this angle is 120, right? And the 2 alpha is also equal to 60, right? So 120 minus 2 alpha equals 60, right? So now you know alpha equals 30 degrees. If alpha equals 30 degrees, right? So the angle B is equal to 3 alpha is 90 degrees, right? The angle C is equal to 360 minus alpha, right? Is also 90 degrees. So now we prove two of them are 90 degrees. Okay, so now we have this 30 degrees, we have this 30 degrees. Okay, so 30 degree, 30 degree, then BEC, right? Then you know triangle BEC is also isosceles triangle, right? If angle BEC is also isosceles triangle, then you know A equals D. From BE equals CE. Okay, Now if A equals B, right? A is also AB, right? D is also CD. Now we have the AB equals CD and AB parallel to CD. Now you know ABCD is a parallelogram, right? Because ABCD is parallelogram, okay? So now you know the AD. See, this is the ABCD, right? This is the parallelogram with the angle of 90. So that's why ABCD is rectangle. Done. Next. Okay. So this one is the we have 4 congruent circles tangent to each other. Okay, and here is the big sector here. So it mentioned the radius of the base will be 2/3 of the slant of the height. Let's see. So if you have this one, okay. If you have this one, okay, and you make it as a cone, right? So you know the circumference of the base, right? The circumference of the base. So let's see, this is the r. So you know the 2 pi r is equal to the arc is equal to the arc length. This is the 2 pi r of the arc, right? And this is the this is the D, right? Here is the D. So it mentioned the radius of the base, and the D is the 2/3, right? Means R over D is 2/3. Okay, so that means the 2 pi R over the D equals 4 pi over 3, right? So that means this 2 pi r here is equal to the 4 pi over 3 times d. Okay, so that means this angle is 2 pi over 3, like 120 degrees. Okay, now we have this one is 120 degrees, right? Okay, now let's redraw it. Draw a better picture here. And by symmetry here, okay, you can see it's we can have some tangent lines. Okay, so now let's some tangent lines, right? So the center is here, right? And we have another tangent line is here. So we have the midpoint, right? It's M and N, right? This is the A, B, C, D, right? And you can see by symmetry we have four of the circles here, right? So we should by symmetry because this is the 120, right? So this is another 120 by symmetry. This is another 120, right? So that's 360. So you can see here is the regular. It's a regular hexagon here. So now we can do the right. So we can see this is the P, right? If we set the PT is 1, because we only want to test the ratio, right? So if PT is 1, and now we have the this is the X, right? And then this is the X is the radius of the small circle, right? So now it's the 1, and X and X. Okay, so you can see, because I mean this one is the 60 degrees, right? So we can have this one is the 60 degrees. So we can have the 1 minus X equals 2X, okay? Here is the 1, so 1 minus X, because here is the X, right? So this is the 1 minus X is here, and then this is the 2X. We have a equilateral triangle here. So now we can see the X equal 1/3, okay? Let me draw it to make clear, okay? Okay, so here is the center, here is the center. This is the 30 degree, this is the 30 degree, so this is the 60 degree, right? And this two, the center is the same length, the equal length. So this is the circle, right? So here is the touching point, here is the touching point. So that's why this is the X, this is the X, right? And this is the 2X because it's passing the tangent point. So this is the X, this is the X. And this is the 1 minus X, right? So that's why you have the 1 minus X equals 2X from the equilateral triangle. And then you have X equals 1/3. If the X equals 1/3, then you can calculate the ratio, right? And then the ratio will be, so the ratio of the radius of sector is 1 over 1/3 is 3. Okay. Then next, so the ABCD is a square, and the parallel lines. Let's draw ABCD is a square. Draw ABCD is a square. Then parallel lines passing the ABC and between the, okay, so we have some parallel lines passing ABC. So we know that AB, the distance of the AB is 7. So this is the 7, and the CD is 9. Okay, so okay, so like this. Let's draw a picture. So this is the M and P. M and P, they are parallel. Then we have this one is 7, the other is 9. Okay. So normally when you see this, right, for the square, and we have the 7 and 9, we need to find some ratios. So let's do the similar triangles. Okay. So we need to find some similar triangles. Okay, so here is the similar triangle. So we have the similar triangle is, let's connecting the diagonal. right? So we have 90 degree, 90 degree, and this angle equal this angle. So according to the AA, we have the this is the P, this is the Q, this is the R. Okay, we have the APQ is similar to triangle CPR, and the similar ratio are the 7 to 9, right? Okay, then you know it's 7 to 9, so that means the AP over CP is also 7 to 9. Okay, now let's see, we have another similar triangle. That's the let's see, this is the M. We have another set of the similar triangle, right? So we know the M, the AM over the BC, right, is also equal to the AP over CP is 7 to 9. Right, so that means if we say this is the 90 and this will be the 70, right? Let's parameterize the length. So this is also the 90, right? So now we can see that we have a triangle the MAB, right? So here, so it's 70, it is 90, and this one is 7, right? So let's try to see whether we can solve this one or not, right? So this triangle we are very familiar should be that is this is the alpha, and this is also the alpha, right? So we know the tangent alpha is let's draw us to alpha, right? Tangent alpha is 7, 9, and so this is the 81 is 130, right? So that's why we know it the 7t, right, basically is equal to 7 over cosine alpha is 7 over the cosine alpha is 9 over 130. So now you know the 7t is equal to the 7 over 9 times 130. Right? Okay, you know the 70. Now what will AB is equal to 90, right? Is equal to the 7 times square root of the 130. And what? Okay, so now the square is the $70 is this. 70 is this. Okay, I'm sorry. 70 is this, right? So t is equal to the 1 over 9 square root of 130. Then the 90 is the square root of the 130. So the AB square is 130. Okay, next. So the chord xy and the tu of the circle bisect each other. Okay, and xy also equals tu. So we have a chord of the xy Okay, we have a chord of xy and tu bisect each other. Let's see, this is the center of the M, and this is the center, right? Okay, so here is the tu is a midpoint. So if we know the xm equals ym equals tm equals right? This is what we know. Because they bisect each other, they also have the same length, right? So now we have a now we know we have a equilateral. We have a isosceles triangle here, right? They are congruent. Okay, so we have the angle is alpha, alpha, and alpha and alpha, right? So now we know now we know the arc. Okay, now we know the arc of the tx is equal to the arc of the yu, right? And also because this angle, these two triangles are congruent, right? So you know the ty also equals xu, right? Also, that means the ty arc is also equal to the xu arc, right? So now we have the tx arc plus the ty arc is equal to the yu arc plus the xu arc. So here you have the xy arc is equal to the yux arc, right? Xty arc means what? So this is the arc, right? This is the whole circle. If you divide the whole circle into two equal parts, right, means each one is half circle, right? So xty equals yux equals half circle, right? Equals 180. So that's why the xy and the tu must be diameter. Okay, then we prove it. They must be the diameter of the circle. Okay, they intersect at the center. Next, so this one, okay, normally is when we deal with the circle, okay, there are some if we see the tangent point, okay, so each of these circles have the radius of 15, okay. So when we deal with the tangent point, we always connect with the center with the tangent point because there is a good property of 90 degrees. So we have how many 15 we have? 15, 15, 15, 15, right? And we always do this, and the n is bisecting perpendicular bisect the EF, okay? So we are trying to solve what is the EF, okay? So now let's see, we have a triangle here, we have a similar triangle, the AMN, okay, and AGP. So triangle AMN similar to triangle AGP. Then we have the MN over the GP is equal to the AN over the AP, right? AN over the AP 1, 2, 3, right? Is 3 times the radius, and the other have 4, 5, right? 5 times the radius. So that's why it's 3 over 5. So now you know that mn is equal to 3 over 5 times 15 is equal to 9. So you know this one is 9, this one is 15, right? So if you know this one is 9, that's simple, right? So the Pythagorean theorem, okay? So here is the EF, here is the N. You know this is 9, you know this is the 15, right? So you can calculating EM, right? So EM is equal to, you don't need to calculate, it's 3 times 3 equals 3 times 5. This is the 3, 4, 5, right? So this is 3 times 4. So the EM is 12. Now if the EM is 12, so EF is equal to 2EM is equal to 24. Okay, next. So find the volume of the sphere that is inscribed in a regular octahedron with a side length of 12. So the octahedron is this. Is a square base. Okay, and each of them is stick out is a equilateral triangle. Okay, so it's this. Okay, so this is the octahedron. Okay, so now we need to find a point, right? And that is inscribed in this face, means from the center to the face of here and to the face of here has equal length. So you can see, because by symmetry, right, the center can only be selected on the center of the on the middle plane is O, right? Okay, now let's see what is that radius. Okay, so we can construct this one and we can construct this one, right? So you can see this one. Okay, so this one is perpendicular to the face. Now let's calculating what's that. Let's extract this AOB. Now let me extract this AOB. AOB, and this is the x. Let's solve the x, right? Okay, so the regular tetrahedron have a side length of the 12. Okay, so this length is 12. If this length is 12, so OB is half of the side length. OB is 6, right? And this is 12, so this triangle we have an equilateral triangle. We have an equilateral triangle, right? So this is the height of the triangle. So this is the root 3 over 2. So this is the root 3 over 2 times 12 is equal to 6 root 3, right? Then we can calculating this height, right? So this is the 6 root 2 based on the, you know this one, you can calculate it. It's a Pythagorean theorem, right? So based on the Pythagorean theorem, now we have the two similar triangles. Up to here is very standard, okay? So we have a similar triangle of this one is similar to ABC, right? E. Triangle AED, AO is similar to triangle AOB. Then x over 6 square root of 2 is the leg over the hypotenuse is equal to the leg over the hypotenuse. So you can get x equal to the 6 root 2 and root 3. Then you can calculating the volume, right? The volume of the sphere is 4 pi over 3x cubed. Okay, so it will be 64 root 6 pi. Next. So in the left figure below, O is the center of the, find the area of the region, give the AOC is 120, this is 120, right? And the OM equals OC is 6, so the radius is 12, right? So basically the shade, this is simple, is equal to the area of the AOC minus the triangle of the AOM. Okay, this is very straightforward. The answer is next. So this is the erected problem again. This is how we can second method to prove the Pythagorean theorem. And you can see we have a triangle ABC that we erected. Erected with a square. Right, so these are all the height. So based on the height, right? Because here is the 90 degrees. Based on the height, so you know this must be the orthocenter, okay? A, B, C. You know this must be the orthocenter. So all these are the height. Okay, so it wants us to prove that the R3, for example, this R3 equals R2, right? Okay, let's see how we can do it. Let me notate in some point, maybe the D, E, F. Okay, it's a foot. Then you can see, let's see, okay, based on the triangle, this is the C, right? This is the C. So this angle plus this angle C in triangle ADC, this angle plus this angle is 180. So this angle is 90 minus C. And also this angle is 90 minus C. Right? So that's why the BEC, triangle BEC, is a 90C and the 90 minus C triangle. And the triangle ADC is also a 90C and the 90 minus C triangle. So they are similar, right? If they are similar, okay, that means the AD, let me see, CD, okay? That means the CD over AC, that means CD over AC, right, is equal to CD is equal to the CE over BC, right? Then we can have the CD times BC is equal to CE times AC. Okay, let's see what is CD times BC. So CD is CD, right? Times BC. So BC is also equal to this side, right? Because it's a square. So CD times BC is equal to R2. Then CE times AC, right? Times AC. AC also equals AC is also equal to this side, right? So CE times AC is R3. So that's why they are equal, okay? Similarly, okay, you can use you just need to find the rest of the some other similar triangles, okay? For example, the ABD is similar to triangle the CBF, yes, okay. You can prove all the other area are the same. Okay, so if it is 90 degrees, right? Think about it. If it's 90 degrees, we have 90 here, we have 90 here, right? So that's why you have the this one, this line and this line will be collinear, right? And also you will have this line and this line will be collinear, right? So and now you don't have this area, you don't have this area, right? So R3 plus R so R3 equals R2, and this the R6 equals to R1. Then you have the R3 plus R6 equals R1 plus R2, right? Then what you have, what's this? This is the area, right? So then you have the A square, this is A, I mean this is the C, this is the B, then you have the A square plus the B square equals the C square. This is the Pythagorean. Okay. Next. So we have this one, we want to prove we have a rectangle prism. Okay. Let me point in the ACF on the diagram. So ACF, right? Okay, so we want to prove the triangle ACF is a acute triangle, right? To prove anything is a acute triangle, for example, the ABC. Let's see the ABC. Okay, let's without loss of generality. Okay, this means without loss of generality. Okay, so without loss of generality, we always can say A less than B less than C, because otherwise three sides, right? You can permutate, you can line them up from the smallest to the biggest, and we want to prove that A square plus B square less than C square is the obtuse. The A square plus B square equals C square is right, and A square plus B square less than C is greater than C square is acute. Okay, all this is from the law of cosine. Okay. Now let's parameterize this. Okay, so let's see the height is A, B, C, the three perpendicular sides. Then we have the AC square is, let's say the A less than B less than C. So AC is equal to the A square plus the B square, and AF square is A square plus C square, and CF square is B square plus C square, right? Based on the A less than B less than C, we know this two relative small, this one is bigger. So AC square plus the AF square, So we know the AC less than AF less than CF, and let's do the is equal to 2A squared plus B squared plus C squared is greater than the B squared plus C squared is equal to CF squared. Now we prove this is the ACF is a acute triangle. Okay. Now, question 28. So, question 28. So we have the AB. Okay, we have the trapezoid ABC. We have the trapezoid ABCD, and then we have the BD and AC are the diagonal, right? Then we have the AB equals 8, and M is the midpoint of the BD, and the N is the midpoint of the CD. We want to prove MN is perpendicular, the N is parallel to AB, right? Okay, so let's see this is M. Okay. And so we can see if this one parallel to this one, right? So we have the triangle AOB will similar to triangle COD, right? And you can see then we have is the AO is equal to the 8 of the P, then the CO will equal to M times the P. Then the BO is equal to A times the Q, then DO is equal to M times the Q, right? And we know the M is the midpoint, right? So the BM equal to DM is equal to half of the M plus 8 times Q, and AN is equal to NC is half of the M plus 8 times the P. Okay. Now we can solve the ON, right? So the MO is equal to the DO is MQ minus half of the M plus 8 of the Q is equal to half of the M minus 8 times Q, right? MO and NO you can similarly is half of the M minus 8 times the P. Okay, now we can see the MO over NO is Q over P is also equal to the BO is also equal to the BO over AO is Q over P, right? So we have the ratio is equal, right? And also this angle equal to this angle, right? That's why we have the these two triangles similar, right? Triangle MON is similar to triangle the BOA. Then you have this angle equal this angle, right? Then you can see the MN will parallel to AB. Okay, the second question is can we find the CD? Okay, let's try to extend it because this is the midpoint, right? So R is also the midpoint and the S is also the midpoint, right? So in the triangle ACB, right, the NS is the midpoint of the segment, right? So this one is 4. And in the triangle ABD, right, so the RM is the midpoint, so this one is also 4. and this one is tell you is 6, right? So you know the midpoint segment of the trapezoid is 16 is 8 is 14, right? 14 equals to half of 8 plus m. Then you can solve m equals 20.